Right. This video is the 150th video so of this channel about the high energy particle, HEP particle or handwritten um, HEP. I've started this channel still almost 3 years ago, and as I did for the 100th video, I want to summarize the what I covered in this channel for the high energy physics area. So I used some ChatGPT to analyze the previous videos, which areas that I covered, and some statistic. So when I analyzed this, there was only the 147, and there is uh, additionally the two videos added after that. So they are pretty it. And also the when I did the analyzed 100 the number of videos almost a few months ago, I just make some classifications of each areas in this presentation slide. Also I did this, but I will not use it in this 100 pips TS analysis. So first of all, um, I started studying this channel through with the first topics of the neutrino relations in the 3 years ago, 2022, so almost 4 years ago. And at the first time, I covered the very simple topics in the particle physics and quantum field theory, like the neutrino relations and the local gas imbalances thing. So first, the GPT give me the number of the videos in each year. So in the first year, the 2022, the number of the videos is just 6 because I started in channels almost November or December, I remember. Uh, at this time, I begin the some fundamental concept, and the next year, 2023, I entered the graduate school. So the some systematic and the theoretical foundations are added. And during the 2023, because I made this videos during every week, continually, so the number of the videos is almost 44. So the percentage is very high compared to the other year. For the 2024, this is my second year of the graduate school, and I have some psychological and some issues in my life. So at some moment I stopped making the video. So the total number of the videos are reduced. And the topics also transit to the some research topics and some advanced area rather than some fundamentals and theoretical basics. And the next year, 2025, the number of the videos again increases. The topics are also broadly expanded across the particle physics, and it's partially that I cover the many topics in the cosmology. This year, 2026, until the July 15th, when I analyzed this statistic, the number of the videos was 30. And in this year, I changed the format from the handwritten note to the text based video, and also channel names changes from the handwritten HEP to the HEParticle. So the total numbers at that dice are 147 over the approximately the 1,300 dice. So the GPT gives me that the statistic approximately the 1 billion average the 9 days, and each week I made 0.8 video, and for each month almost 3 to the 4 videos, and per each year 40 videos averages. So in the 2022, the first videos that are very central ideas of the particle physics, like the neutrino relations, which is the my first topics in my research area, and the local gauge invariance and asymptotic rhythm, as some contemporary theories around the gauge theory, and I covered spontaneous metric breaking for the particle physics, and I'm a study box in the neutrino relation, and ghost based in the non-abelian gauge theory. So this is the first 6 videos in the 2022. Next one, in the 2023, I covered several many areas. there are also various topics. But still there are some particle physics and contemporary theory like the Higgs mechanism, require interaction, and the system mechanism for neutrino, jet boson resonance in the electroweak theory, and also I covered some cosmology and relativity theory here. Also simple derivations of the propagated in contemporary theory, lift collection, and also I covered some supersymmetry theory like the superspace formalism and the capacity to fulfill theoretical particle physics and the supersymmetric Lagrangian here. So there are also many topics in the supersymmetry, and also I turn to the particle physics here, cosmology, and also those. Yeah, there are some many topics in the supersymmetry like the color multiplus, supersymmetric Lagrangian, and also for those many loop collections in contemporary theory. There are some Piper theory counted in. Again, the Suzy breaking, and also the characteristic of the 2023. I started researching some biogenesis in the early universe, that I covered some topics in leptogenesis too. Also, I covered supersymmetry breaking models with the mediation from the hidden factor cell, because I started researching in this year when I entered grad school. Also, the catastrophic parameterizations for the leptogenesis, RG evolutions for the supersymmetry, okay, also the particle mass spectrum, neutrino factors, also parallel relatives and leptogenesis topic. And there's topics in the particle physics and the cosmology. Action, thermal dark matters, which is in stars lives dark matters, and also early universe in the thermodynamics, and the simple particle physics, contemporary theory, again the supersymmetry. Yeah, so in the 2023 I covered so many topics in the contemporary theories, supersymmetry, cosmology, including the leptogenesis. The next year, 2024, my topics becomes the extended about the total numbers reduces. And some lectures tried to organize, but I didn't finish this particular physics lectures, even though I made this the lecture note here. So this is for 2024. The decay examples of the happy neutrinos and the supersymmetry particle are just my research. And there is a particle physics lecture trial 1, 2, 3, but I didn't finish to make this. There are some notes, but I didn't make all the video. And topological solution. At this time, I think I remember that this is a 2024 summer, almost July through August. I make each higher physics topics for study. There are some now continuous series. For each month, I made just one topic for the study with the other members in our lab. And the first topic was topological solution or topological debug. And the continuous topic was some instantaneous parallel and effective reaction potentials, including the Coleman-Weinberg potential, and also I turned to the GUT, grand unification theories, in the 2024 October, I remember. I studied myself about ST5 representations and the positive proton decay as the barren number violation process, and turn to the gauge coupling learning unifications and the non-minimal GUT like as SO10 and the supersymmetric version. And also it covers the many topics in the action in the 2024, like the relaxation for the Higgs mass and the axion clarity problem arising from the quantum gravity correction. And also I try to understand about the many things in the cosmology, like the inflation theory and the cosmological perturbations in the Newtonian and the Zia, but I didn't finish the perturbation theories at that time. Also, I covered about some non-standard supersymmetry, but this is the start of 2025. I covered many topics in 2025, so that the topics and there's areas extended and very wide over the ranges of each subject. So this is for the non-standard postmatic like as a non-normalizable color potential, superpotentials, and the R-particle term and the suitable Vikings of term. And also includes the gravity-based interactions and cosmology, but I should cover some times about this gravity cosmology in the pictures. And also the new problem to resolve the some discrepancy between the scale of the SUSY breaking and the conserving parameters. And there are some proposed resolutions of these new problems, such as NMS system with the additional singular data and the Kim's mechanisms adopting the one-peak action models together. Also, yeah, there are some very specific topological boxes in the early universe. And after the Kalman potential also covers about the generating functions and the effective actions triple connected and one PI diagram here. Yeah, again the Kalman potential here. And in 2025 summer, I turned to the superconductivity for my research. So I studied about the solid state system. As a microscopic version, there's a BCS theory with the Cooper pair, and there are microscopic effective descriptions, which is the Ginzburg-Landau theory with the spontaneous metric Vikings regime. But again, still I cover and focus on the high energy physics. Some topics in here. Okay, also I just overall list review on the compatibility related to the chart. And also various topic, cosmology, gravitational wave, upright time barriers analysis and manipulations in the early universe. Okay, so also I covered in the 2025 July in the summer and August. I try to make the higher speak notes to save the my studies, but the writings, all the notes is how to manage the again. So I just captures some images of textbooks or the lecture notes and making it myself. The virtual was electroweak variations in WBC, and I understood about why the most of the Python transitions requires to generate enough balance matrix in the DCWBC model and the two vector model is that typically adopts. Again, at the time, I take the Cosmos School hard disk in the IBS TPU, and I learn about impulsion theory and the cosmological perturbation, CMB, past spectrums. But at that time, I can't develop rope stamps. Actually, I lost something, but there's not well organized. And after that, this year, I tried to organize it with some overlives the latex versions, and now I summarize this in this year. And again, the covering the leptogenesis with the low scale model with the half node version. Yeah, and then this is just start through here. Almost 1 year ago, 2025, I remember the September or October, maybe the September, there was 100 years videos of the handwritten have this channel, and I covered what I explained in this channels during the total number of 100 video. So after that, I want to explain what I did in after this 50 video. So first of all, I covered some my achievement since the 2013, and also the together in the Nobel Physics Prize, and one more time of the ham notes at that time. At the time, I didn't make some overlap talks. I mean the light type versions of the HEParticle note, just capturing the copies in the presentation slide. And at that time also I covered some topics in gravity, like the weak gravity conjecture, black hole superradiance, and the and anti-digital spice. Again, the thermal field theory, I think so this was the topics in the HAP studies in my lab. And also at that time I have some interest in the some modified gravity, like the Jordan and Einstein primes of the CR. In the Einstein primes, the GR path is written by the standard Hilbert action, but in the Jordan prime, um, there is upward gravities here. And also I cover the dynamical dark energy, including the quintessence and the local supersymmetry. Also, this local supersymmetry is route to go the superstring theory. Yeah, there's also some advanced topic, technical and compositeness, like as the additional color QCD and the composite Higgs neutrino mass model, including the radiative neutrino mass. This is a very advanced topic, I think. And also learn with the nonlinear potential. If there are some occultic term in the scalar, then the scalar fields are localized, unlike the typical light dark mass model. Also, I cover the introduction to string. Maybe I report to the some um, advanced metric book. Stray neutrino production and neutrino free streaming in the cosmos. This is also very hard topic. Holomorphism and non-normalization theorem. This is the some supersymmetric gauge theory, also I covered in this year. QCD phase diagrams in the temperatures and the chemical potentials axis. There are some phase transition from the universal, but in very low temperatures and high chemical potential, there are some QCD superconducting phase exist. Ultra high energy cosmic light UIGCR briefly. And also the heavy dark matters, including the primordial black holes and the composite dark matters, a very hot topic. So this was 2025 September, and 2026 now I change this the format from the handwritten form to the overall light text version. The first topic was the wave dark matters, which is my main research topic. So I just summarized the overall topics of the wave dark matters, including the mass scale dynamics, Schrödinger Poisson equations, and its solitonic behavior. Now, after this summary, this is very helpful to understand sort of my recent research and the future directions now. And after that, I covered sort of the dark energy from the observation, some of the problem like cosmological constants or coincidence one. And the recent study data also reports that the constant dark energy, like the cosmological constants, does not be with the observation data. So we should make the dynamical dark energy like as the quintessence, and I covered this in this video. And after that, I also talk about the preheating with the parametric resonance. After the preheating, in Platon fields oscillates, and this makes us time-dependent frequencies. Then we can describe the system with the material equations, and there are some specific parametric structure. And there are some narrow and broad resonance regimes, and depending on the parameters, the system can go to the exponential growth, so-called the parametric resonance, and this phenomenon is called the preheating. Such a concept is very important for recent research, especially in this 2026 this year. Also, I covered about the n greater than 1 supersymmetry, gravitational wave resist, non-abelian gauge loss resist. Mr. Lie mechanism and action abundance in the exact formula, extension reluctance factors, up and down genesis also revisited here. I try to also make reviews after the participating in the conference, but not keep going. Also, I try to make general reviews, but this is also not maintained. Also, I make the series of the cosmological perturbation in this year, starting from the Newtonian gravity. This is applied to the non-relativistic and the subhorizon regime. And after that, I turn to the some GR versions of the cosmological perturbation, including the metric perturbations and the matter perturbation, and this can apply to the directly into superhorizon regimes and relativistic radiation. Also after that, cosmological perturbations that is I cover some superhorizon and the adiabatic condition. Then the dance perturbations related with some curvature perturbation term, and the superhorizon assumptions simplifies the complicated equations of the dance perturbation. And after that, I applied to the methods and the radiation path spectrum recently, almost I think 3 weeks ago, or a few weeks ago, or a few months ago. And I just makes how the matter path spectrum depends on each K model and the For the radiation power spectrum case, I cover the baryon acoustic oscillation, and after the CMB, primordial perturbation from the impulations and observation with the another and R. I didn't finish the cosmological perturbation series. Maybe it will finish this in the total numbers of the 8. Maybe I allowed it on for the 6 or 7. Yeah, supervisor and adiabatic condition here. And also I covered the main and the QED remuneration again. Okay, cosmological perturbations no matter power spectrums, how the KT pendencies appear. And after that also I expand the dynamic dark energy with the supersymmetry origin in the dark energy quintessence model. The inverse potential energy can be might be naturally arising from the color potential in the supergravity, and this can also preserve the radiative correction by the non-linear normalizability theorems of the SUSY. Also, I covered again topics of wave dark matters with the shrouding of photon equation, and there are some interferences of the wave structures and the solitonic density compiled arised from the self-gravitating system. So the unadaptable likes the density profiles arise, and this can resolve the small cups problem through the dwarf galaxy. So again, the cosmological perturbations with the photon baryon fluid, which is induces the baryon acoustic oscillation BAO in the CMB signature. Again, implications, the Swarovski implications. In the last years, I covered some transformation between the Jordan's and Einstein primes, and this can be directly applied to the Swarovski implications. The R scale term, the quadratic orders of the Riemann tensors, that's the example of the hypergravity. And if we change this hypergravity to the standard Hilbert action, then there will be the additional scalar degree freedoms of the order, and this can satisfy the lower conditions with some Swarovski types of the potential. Maybe that I can use these implications in my research in the future. And also, I tried to make some series of advanced theories, including the gate theories, and maybe the next I will turn to some superstring theories for my research, for my interest, but not directly related to my research topic. So in the advanced theory, there are some conditions of holomorphy. This can provide very strong conditions, so-called non-normalizable theorem. They directly apply to the ADS potential and acidity depending on whether the number of the fibers is large or the number of the charge color is large. Again, the primordial fluctuations and cosmological perturbation. And again, the cyborg duality, if there are some independent degree freedom is not enough, then we can make some dual build to describe the low energy supersymmetricity. So this is a very recent. The Cosmos School in this month, the 26 July, I participated in the Cosmos School in ICTP, and I summarized this lectures based on my written notes about nonlinear perturbation theory, implications CMB, dark matters, large-scale structures, and gravitational wave. So in the 2026, the master changes from the handwritten notes to the handwritten form to the light up text. So I already covered so many topics. Yeah, there are just some analysis about the AI with topics. So against the main subjects for this each year, 2022 fundamental, 2023 QFT, it's especially the supersymmetries and the early universe cosmology. And 2024, there's some 12 of the lectures and some research applications based on the help study. 2025, yeah, very expansions of the topics over the wide ranges. And that's 2026, now the changing the moment now. Again, yeah, so we can classify each areas research field. So first of all, I covered neutrino physics in the very earliest moments of this channel. The first video was on neutrino relation, and I also covered the MSW effect in the matters. Here's a mechanism for the small neutrino mass. Neutrinos mass ordering, causes parameterization, leptogenesis with heavy neutrino, and neutrinos cosmology. So because I entered this particle physics research with neutrinos physics that possible, I try to make the many videos in the neutrino physics. Also, the dark sector is a very important ingredient to establish the model. For example, the typical dark matter now is the assume that the thermal DM, like as the wind and the beam, but there are also ultralight mass ranges, including the axion. Axion part is very uh, wide, and especially my main research topics is focused on the wave dark matters. So not only those relations behaviors, but also recently I tried to understand sort of the solitonic structures with the inhomogeneous spatial distribution. And also the dark analysis are very important, but very recent topics that I started to understand, especially the dynamic dark analysis, including the quintessence. The cosmology is complementary areas of the high energy physics to test some models and making the new physics, because there are some many tension and the problems in the very early universe. We don't know the some exact theory, almost unknown. So, for example, the standard cosmology like the BBN, CMB recombinations is well known, but the very extremely unknown universe is the not well established. For example, impulations, and after there is the preheating, and there's some baryon to generalize the baryon symmetry and some cosmological phase transition. And also I cover about the cosmological perturbation theory, how the large-scale structures are made. I recently covered with the series of the video. Also, supersymmetry is the form of the very large fractions of my channel. At the first stage, when I entered the grad school, the supersymmetry is one of the branches of the research project. So I covered about some algebraic point of view and some theoretical foundation. For example, the supersymmetry algebra, superfield, and how can construct Lagrangians in the supersymmetric invariant bosons, and phenomenologically and the particle one is how the supersymmetry is broken, and there are several models, and especially I focus on the mediated supersymmetry breaking. And by after the RG evolution, so we can obtain this particle spectrums and the decays of them. But not only is this phenomenology, we can also extend this to the supersymmetry theories, including the gauge version or extension like as the NMSM, RPV, local thesis for the string theory, and non-normalization theorem to apply to the supersymmetric. These are I focus on them, but I don't know that this is directly directly becomes relevant with my research topic, because my research is related to the some breaking some mechanisms for the phenomenology, but these topics are some too theoretical. And again, this is some foundations of the contemporary theory. In the first time, first title of this channel, I covered some basic like the gauge theory, how the symmetry is broken spontaneously, loop collections for the asymptotic freedom, several symmetry, and after that I turned to some advanced topic like the loop collection, counter term, normalization, and eventually the effective the potentials and the thermal field theory. And recently, I covered some topological debugs, instantaneous non-perturbative contributions, and yeah, that's something like that. So the points of this contemporary report, there was some symmetry, but these symmetries might be broken, sometimes preserved, and some page transitions from the symmetry phase to symmetry breaking phase, and can make some topological debug. So Again, there's some of the patterns. For example, the I try to understand the cosmological perturbations in the birth size of 2023, but I can't finish this at the time. Again, I try to one more time to understand about the cosmological perturbation. At that time, now now is the arrives in the GR versions of the cosmological perturbation. After that, now that there are some systematic 7 parts of the series for these cosmological perturbations in this year. So the it almost pumps sort of the 3 years to understand sort of the one area. And again, the supersymmetry, so at the both sides, I try to understand sort of very basic and the foundations of this area. But after that, now I try to understand sort of extensions of this model, non-trivial, non-minimal, and some theoretical extensions of the supersymmetry. Also, there are some examples of axion physics. I try to check and remind the various topics in axion, like the relaxion, axion quality problem, and the related with axion abundance against the both neutrinos and the leptogenesis. So there are some of the patterns. I try to understand some specific area, so I make some introduction, and because at that time that was not familiar with me, so but it was a seed. Then after that, um, that's some specific topics that becomes the major, getting better to understand, more getting better, and next year, and some mathematical foundations derivation, and how can I apply this to some specific theme, then now that I can be applied to the research level directly. And these patterns and these cycles becomes more faster than the previous moment. So, for example, the parametric structure sort of this year, I understood this in the very early stage of this year, but directly applied to my research after that. So, so the point is that this harness particle physics channels that after 2022, starting this possible research projects with the grad school is quite helpful and um, complementary helpful. I don't know some exact how can I say so helpful ones to my academics journey. And there's also the many other systems, not only this HEParticle, but the many systematic way to understanding the something academics the specific area, and that's also for the um, for example, just making the academic paper list or some summarizing a specific topic. The point is that that's a very good systematic way to learning and extending and applying to this directly to the research. So, um, again, I demand that to the AI, demand AI to list through the video after the 100 to um, cover what I did, but I already talk about it. So here's the conclusions that already I talk about some specific general features of this channel, and this is very helpful, and almost 2 years post year, and I hope that I can continue to solve and studies in this area, so high energy physics, especially the theoretical and fundamental analysis with the particle physics thing, and hopes everything's keep going on and very well. Another conclusion, yeah, does know. So also for the practice English is via this channel too.